most important single word describing the components in any refrigeration system. There are three main circuits that make up all cooling systems. The first circuit covers the flow that actually removes the heat from the intended product or people. It is usually air, but can be water or any other medium for heat transfer. The electrical circuits are equally important, for they provide power and make many of the decisions for the system. But the circuit that makes heat removal possible is the refrigerant circuit. It is this refrigerant, continually flowing and feeding the evaporator, that takes heat from where it's not wanted and moves it to where it will do no harm. Protection is important for all parts of the cooling system, but in the refrigerant path, circuit protection is critical. Most of the other components in a refrigeration system have other means for protection, including hearing or seeing the problem. Not so with the refrigerant circuit. This circuit is closed, totally sealed, and is never opened unless absolutely necessary. It must be as clean as possible when it's sealed, and should any contamination develop, the system must remove it so the circuit remains clean. To do these two jobs, we need the system protectors. The very names of these devices give us a clue as to what could go wrong in the refrigerant circuit. These killers can be divided into two broad categories: soluble contaminants, such as water, acid, or wax, which can be dissolved in the refrigerant, or the insoluble contaminants, like metal chips, sludge, and flux. While the entire system will suffer if these contaminants are present, their primary victims are compressors and any components with small orifices like expansion valves and solenoids. Expansion valves, for example, are made up of a number of close tolerance parts that must be free to operate smoothly and evenly. The orifice, by its basic purpose, must be small. It doesn't take much contamination to shut a TEV down. Water that has been dissolved in refrigerant can condense and freeze if allowed to reach the valve orifice. The resulting ice crystals will clog the orifice and cause starvation of the evaporator. Clogging can also come from the other contaminants, whether they be wax, metal, or sludge. All small orifices, regardless of location, must never see these contaminants. The compressor is a metal factory, full of small orifices and close-fitting metal parts, many of them moving against each other. The list of ways contamination can destroy a compressor is too long to even begin. It also works the other way around. The compressor, breaking down for other reasons, can fill the system with the very contaminants that can cause even more damage to the compressor. The process can continue until the worst possible thing happens. The compressor totally burns out. Once that happens, the system will be filled with as much acid, sludge, and other contamination as it will probably ever see. Contamination that must be removed. It is the filter dryer that must be used to do the cleanup, and it is the filter dryer that's installed in most new systems to start them clean and keep them clean. Whether the filter dryers are installed to clean up a system after a compressor burnout, or are installed as insurance to keep a system running cleanly and smoothly, they are a tool for which there is no substitute. They do just what their name implies. They filter the refrigerant passing through them by removing the insoluble contaminants such as wax, sludge, and metal particles, and they dry the refrigerant. Drying of the refrigerant means removing all water, acids, and other contaminants that may be dissolved in it. Since the two primary locations for contamination problems are at the expansion valve and compressor, it's logical for these protectors to be installed at the inlet of each of these components. Filter dryers get their names from these locations: the liquid line filter dryer and the suction line filter dryer. While both types do similar jobs in the system, their construction is quite different. and in general, they are not interchangeable. The reason they are not interchangeable is the same reason their constructions are different: pressure drop. While pressure drop is important in the liquid line, it is critical in the suction line. Every extra pound of pressure drop in the suction line can rob the system of needed capacity, and for that reason should never exceed recommended limits. Limits that are very low compared to the liquid line. It is very common to change out suction line filter dryers because they have done their job well and their pressure drop has become too high. All filter dryers introduce some pressure drop, even when they are brand new. A check of their construction will let us see why pressure drop goes up as they go about their job. Quality filter dryers are built so that all flow first must pass through the main filtering element, a highly compacted filter media with fiberglass as a base. The filter material must be tightly controlled in manufacturing so that it is loose enough to allow as much flow as possible, but still tight enough to do its filtering job. Filtering that may mean removing contaminants that are smaller than the eye can see. After passing through the filter, the refrigerant will flow through the drying element. In quality dryers, this material, known as desiccant, collects moisture through a process called adsorption. In adsorption, water, as an example, is collected and held on the microscopic internal surfaces of the desiccant material. This internal surface area is 10,000 to 100,000 times greater than the actual surface area on the outside of the desiccant bead. The desiccant will collect wax and acids in much the same way. It is important to note that refrigerant flow occurs around the desiccant material, not through it. This special characteristic of an adsorbing material will ensure that pressure drop stays as low as possible, as long as possible. The desiccant material can either be in block form or beads, depending on the application. We now start to see the important differences in filter dryer performance. Quality filter dryer design provides two important benefits. The filter dryer must be built to remove all contaminants, and the filter dryer must never be a source of excessive pressure drop. The service technician's world would be an easier one if there were one filter dryer to do these two things in all situations. No such filter dryer exists. Like so many other things, filter dryers are specialists at what they do. If they are liquid line filter dryers, they can have a higher internal pressure drop, but their adsorbing ability must be high to ensure that no contaminants dissolved in the refrigerant reach the expansion valve. Because liquid line dryers are designed for higher adsorbing strength, installation of a liquid line dryer is a must for making sure the system remains clean of moisture and debris. Liquid line dryers are available in a variety of designs, each with its own capability. Some have higher water adsorbing strength, while others are specifically designed for acid removal. Others are designed for greater wax removal properties. These are particularly useful in R22 and R502 systems. And of course, since flow rate is important to all filter dryers, a variety of sizes is available to match the system flow requirements. In suction line filter dryers, the big need is for filtration, since it is the solid contaminants that are the most harmful to the compressor. The drying function takes a back seat to filtration in the design of the suction line filter dryer. In fact, in some applications, the dryer element is not used, and the result is a component that is all filter. The filtering action of the suction line filter dryer is very high, with the capability to remove solid particles as small as 10 microns, about the size of the diameter of a human hair. Because of its high capability to remove suspended contaminants as well as acid, the installation of a suction line dryer is an absolute must after a compressor burnout. A strong case can also be made for installing a suction line dryer in any system, where long-term reliability is a requirement. While it's true that the liquid line filter dryer will rid the system of most soluble and suspended contamination, the suction line filter dryer is an inexpensive insurance policy against compressor failure due to contamination. Although the suction line dryer will clean up a refrigerant circuit after a burnout, the dryer may lose its value in the process. As the dryer does its job, the contamination picked up will add increased pressure drop to the suction line. If the pressure drop increases beyond acceptable limits, the filter dryer must be removed and a judgment made by the technician on whether to replace it with a new one for additional protection. In the liquid line, the situation is slightly different. Liquid line filter dryers are often replaced, but not because of pressure drop. It is usually because there is still water in the system, and the liquid line filter dryer can absorb no more. To remove the excessive moisture, a new dryer must be installed. It is the liquid line moisture indicator that will tell the technician if moisture level in the system is too high. The indicator has a moisture-sensitive element that changes color as moisture content in the system changes. A color scale on the indicator gives the technician an accurate reading of the moisture level in the system. For convenience, a specially engineered chemical element works with all the common refrigerants. The fused viewing glass permits easy inspection of the system refrigerant so that bubbles or flash gas are easily seen. Since these problems are normally associated with improper refrigerant charge, low head pressure, insufficient subcooling, liquid line restrictions, or improper piping design, the moisture liquid indicator is a valuable service tool for locating system problems. It is a very important partner for use with filter dryers to maintain the quality level of system refrigerant. Moisture indicators should be installed in all low-temperature systems. The moisture indicator will not, however, measure acid level in refrigerant. That must be done by the Acid Alert Test Kit. This two-part kit gives the technician a quick method for determining the acid level in the system's refrigerant. A high acid level is the result of high heat combined with oil and refrigerant. In a compressor burnout, the amount of acid and other contamination is significant, and it is the filter dryers that must remove it. Depending on the severity of the burn, it may be necessary to replace the filter dryers after the initial startup. It is the Acid Alert Kit that will tell the technician when the acid level in a system is too high. In all the system protectors, the signals they send out can tell the technician a lot about the system he is servicing or installing. Even a used filter dryer can say a lot about the system it was in. A filter dryer heavily loaded with a very high pressure drop says something is very wrong with the system. Abnormal operating conditions are generating excessively high temperatures that are breaking down the refrigerant and oils. The result of that process is always the same: contamination that will clog and kill a refrigeration system. The best answer is a lot of prevention and some low-cost insurance. That means using the system protectors. They are easy to use, effective in their work, and always on guard.